All right, so this is our little mini unit on variation. And in the last video, we introduced the main idea when we talked about direct variation. This video will be a little bit quicker probably because it's just going to build on all those same concepts from the last video. But it's going to apply it in a slightly different situation, a situation that's known as indirect relationship or indirect variation. So very, very similar, just a little tweak in vocabulary that's going to cause a little tweak in the mathematics. But other than that, you're going to see this is very, very similar. So with that said, let's get started. The learning objectives for this are basically the exact same learning objectives as we had in the last video. The difference is now we're working with indirect relationships. Notice there will still be a constant proportionality. We're still going to need to write equations, also known as models, and we're still going to solve problems. So everything is the same. The only thing that changes is what's the vocabulary associated with indirect. So to help with that, what I've done is I've jotted down the vocabulary from the last video, and I've jotted down the corresponding vocabulary associated with indirect variation. So if you need to pause the video to capture this, you can real quick. But once you're ready, let's talk a little bit about this. So in the last video, we said whenever we see these three phases, those three phrases all turn into this equation that's a linear type of relationship. Y is equal to some constant times x. And we talked about that in this case, the constant x the same way as a slope would ask. And this is just basically something that's linear. Okay. Now you can see the vocabulary here changes slightly. We're going to be indirectly related, inversely proportional, or indirectly the way we vary indirectly. Okay, so very similar vocabulary, but we have that prefix in that's consistently in all these statements. When you see a statement like this, this will also turn into an equation, but the equation will be slightly different. Instead of y equals k times x, we're going to end up with y equals k divided by x. Y equals k divided by x. So in this situation that we had in the last video, we had a linear relationship. And in this situation, we have, well, when we divide by x, when we have x in the denominator, we talked about 2 chapters or 2 weeks ago that that is a rational equation, a rational relationship, a rational function. Okay, so this is a linear function. And that's a rational function. Okay. Now, as far as the way these functions behave, I want to contrast these two things real quick, and then we'll get into an example. If I have a linear function, we know, because we've worked with linear functions often enough, that it's going to be a straight line. And we talked about in this case, because b is equal to 0, my straight line will go right through the origin. So notice what happens in a direct variation problem. If my x number gets bigger, my y number also gets bigger. Okay, so when I move to the right, I move up. Okay, so the two go hand in hand. If my x number got smaller, my y number would also get smaller. Okay, so that those two things go together. If I move from this point to this point, my x number got bigger and my y number got bigger. But this is going to be a rational function. And we know from the last chapter that rational functions don't act like that. Rational functions are these bendy shapes, right? These types of shapes. Okay, and so notice what happens in this situation. If I start at this point right here, and my x number gets bigger, so I'm starting right here, and my x number gets bigger, what happens to my y number? Well, my y number goes down, is what happens. So in a direct relationship, if x gets bigger, y gets bigger. If x gets smaller, y gets smaller. But in an indirect relationship, it's the other way around. When x gets bigger, y gets smaller. And vice versa. If I were to go backwards, if I were to start at this point and go the other way, my x is getting smaller, but my y is getting bigger. Okay, so that's the basic difference between these two functions. Really, the only thing that's left is to take a look at an example and to solve a problem. So here's our example. And again, if you need to pause the video to get this written down in your notes, feel free to do that. In fact, since this is very similar to what we did yesterday, what I would recommend is pause the video and try this. Give it a try, see what happens, and then if you get stuck, or if you get to an answer, whichever comes first, then resume the video and see if your work matches my work. Okay, so hopefully you've given this a try. Notice we have here that R and S are this indirect relationship. They vary indirectly. And so that tells me that I'm going to have an equation that has a fraction. And for my equation, I want to relate R to S. So that tells me that my R is going to be my dependent variable. So it's going to be R equals, and then my fraction is going to be K divided by, and in this case, it's going to be divided by S. So that would be my first step. Exactly the same as it was in the last video, except for in the last video, we multiplied. In this video, we're dividing. Same first step. Okay, now, once we've got that same first step done, the first thing I want to do is find my constant of proportionality. And so to do that, I'm going to plug in the numbers that they gave me for R and for S. So R is 27 when S is 1/3. So in the bottom of my fraction, I get a 1/3. Okay, now, as I mentioned in the last video, there are a lot of ways that you can solve this. Some people would immediately simplify this fraction because they don't want to have a fraction inside of a fraction. And that's legit, nothing wrong with that. Some people would look at this and say, I'm dividing K by some number, and so to cancel out division, I'm going to multiply both sides by that number. That's legit, doesn't matter. Me personally, because I want to try and communicate a consistent method that works throughout all of these different types of problems, what I'm going to do is go back to what we did when we were solving rational equations. And when we solved rational equations, what we did was we took the number side and we put it over 1. And then that enabled us to do a cross multiplication problem. So I'm going to cross multiply, and in one direction, I'm going to get a 27 times a 1/3. And in my other direction, I'm going to get a 1 times a K. And so when I cross multiply, I end up with those two expressions equal to one another. So 27 times 1/3, a lot of different ways you can do that. You can put it over 1 and multiply and simplify. You can think of this as being division. You can just type it in your calculator, 27 times 1/3. No matter how you do this problem, though, the right answer for 27 times 1/3 is a 9, is what you should get there. And of course, 1 times K, well, that's just equal to K. So through this process of cross multiplying, or whatever method you used, we now know what the value of K is. So if the question asked me to find the constant of proportionality, I would be done right now. But that's not what it asked me to do. It asked me to find the equation. And remember, it could also say find the model, right? Equation and model mean the same thing. So now what I need to do is I need to take this function, this formula, this format that I started with, that structure that we began with, and I need to combine it with this answer that I've come up with, this result that I have found. I need to combine those two things together to make a model. So my model is going to look like R equals something over S, and the something is going to be a 9. R equals something, which is equal to 9, over S. And so that is my model. Okay, now for what the question asked, I'm done right now, right? But we know from the last video, there's a third type of question that they could potentially ask. They could say something like, hey, figure out what the value of R is if S is equal to 3, okay? If the question asked you that, find R when S is equal to 3, if the question asked you to do something along those lines, then we know from the last video, you would just plug 3 into this equation and simplify to figure out what the value of R is. And then that would be our answer. Okay, so depending on what the question is asking, it's the same basic process as what we did in the last video. We're just starting with a different structure at the beginning. All right, so that takes care of indirect variation. Thanks for watching. Have a good one.